Okay, welcome to your Chapter 7 review. I've got 15 problems. I'm going to try to do this in 15 minutes. I've got the problems on the smartboard, so as I get there, you might want to pause if you want to write the problem down, try it, and then see if you get what I get. And I'm going to kind of do these on the fly. Just to be clear, there's going to be 3 equations on the top of the test, and these are those 3 equations, okay? This equation is the one that you really learned in the sequences, chapter 6 section, really when you're what we would call compounding annually. This is the equation that we've learned when we want to compound more than once a year. And then this is when we have things compounding continuously, decaying continuously. There's different types of problems, which hopefully you've done enough of them that they feel sort of comfortable to you. Okay, so I'm just getting my calculator ready here. Hang out with me here for a second. Okay, I'm in business. Here we go. Okay, just to go right off the bat with one of the equations. Say we have $1,000, 5% interest compounded monthly over 6 years. So this would be a situation where you need to realize that we need to use this equation right here. So we write A is equal to A naught, is how we say this, times 1 plus R over N raised to the N T. So A naught is this thing. Sometimes you'll see a P. It just means what we start with. P stands for principal. Times 1 plus R. We need to always take our rate and make it a decimal, so that'd be 0.05. And in this case, if we're compounding monthly, we need to realize that's going to happen 12 times. And then up here, we need to have this happen as many times as it happens over the amount of time, which is 6 years. So this then would be times raised to the 12 times 6. And so now, if you carefully put this into your calculator, which is what I'm going to do myself right now, you would get, hopefully, and I'm going to round this to hundreds, I guess. You would find that you would have, after 6 years, you would have $1,349.02. Next problem. This is what when a situation where we see the word continuously. Sometimes it might say continually. Just be on the lookout. When I see that, I'm going to use this equation with an E in it. Once again, if I have $1,000, this is $1,000 to begin with. I'm going to put that in for this thing called A naught. E to the rate, once again, needs to be changed to a decimal. And then the T is how long it's going to be in. And in this case, it's 3. So we hit the 1,000, and we're going to multiply that by, you want to raise this, and remember I taught you how to do second ln. If you want to make your life easier, it'll bring you an e with an exponent, times 3, and in this particular case you would end up with $1,110.71 after 3 years. Okay, I just want to mention a couple words. Depreciation, interest, decay, these are all these types of problems. So remember, if something's depreciating, say 20% depreciation, it's keeping 80%. So really, this is the problem where we take whatever the original value is, say it's $100, and if it's depreciating 20%, the equation will work this for you because you would write 1 minus 0.2 raised to however much time you care about. But if you recall, really what we're multiplying by is this 80%, and that goes back to chapter 6. And once again, this whole thing with interest is like if it's 5% interest, back in chapter 6 we learned, oh, just multiply by 1.05. But with these new equations, when it says 1 plus r, that would allow that to occur. Decay is always going to be a situation that is going to happen continuously. So decay, when you see that type of problem, you should realize that this is going to be one of those problems where you're going to use your E. So half the battle, I think, is recognizing the problem, what type of problem it is. Okay, here's sort of something a little different, but just to kind of test your understanding in a different way. So say you're told it's the amount of, let's say this is money, given that you start with 1,000, say it's a 5% interest rate, raised to the t being time. Sometimes you might be given a real world problem where you're told that, you know what, t equals 0 is going to be in the year 2011. And then the question is, when does your money double? So this is a case where you're either going to do a little kind of try some numbers and see when you get, so doubling. In this case, if we start with 1,000, we're going to go looking to get up to 2,000. So one thing you could do is try some numbers, but I just want to give you a little kind of helpful hint with your calculator. So another option would be to hit your y equals on your calculator and type in 1,000 times 1.05, and I'm going to just put in my x. And this way I can go to my table. So I'm going to hit second window for table set. I just want to start at 0. And I'm going to go to my table, so I'm hitting second graph, and I notice, as I would expect, at the first year I have $1,000, and then without having to do every calculation, I can just scroll on down and see how much money I have at the end of each one of these years, and I am on the lookout for getting to be as close to 2,000 as I can. And so if I notice here, after 15 years I'm above 2,000, and after 14 years I haven't quite gotten there, so I'm going to have to go to 15 in order to get to 2,000. So then I'm going to come back over here again, and I'm going to say, well, when t equals 15, that is going to be when my money has doubled. I need to go at least 15 years to double. So if someone's asking me, well, what year is that going to occur in, then 2011 plus 15 would equal 2026, I guess. Now, in reality, your money is probably going to have doubled by the time sometime in the previous year, but for the purposes of this problem, I'm just going to look for where it's actually over $2,000, so I know that it actually has doubled. So this is just an application, sort of more real-world application. Okay, a couple other things I want you to think about. Do you know what y equals 10 to the x looks like and what y equals 1 over 10 to the x looks like? I just want to review with you the fact that 1 over 10, remember there's really a little 1 above that. If I were to ship that upstairs, that becomes 10 to the negative 1 to the x power, which becomes 10 to the negative x. And as far as thinking about transformations, this is going back to geometry, what you've done here is you've taken the x and you've made it negative. And if you recall, when you have an x value and you make it negative, you get yourself a transformation which is a reflection in the y-axis. So you should have this understanding. There was a section that you did this, and you should also be able to graph something like y equals 10 to the x and graph y equals 1/10 to the x and understand what that relationship is. So if you are asked something like y equals 2/3 to the x, whoops, y equals 2/3 to the x, and you're asked to graph what that would be with a reflection in the y, you should realize that really all that's going to happen is that is going to become its reciprocal, and it's going to be to the x, because 10 over 1 and 1 over 10 are reciprocals. Okay, some more just kind of plug and chug type problems. So if you are given some sort of an equation and then you're asked to evaluate it, so if I am asked to evaluate this for f of 64, I'm just going to kind of cruise across here and put my values in and see if I can figure out what this equals. Now, in reality, if you're careful, you could just pop this right into your calculator and your answer is going to come out. But just to review, anything to the 0 power is 1. So 2 times 1 is 2. Minus. Notice, this whole thing is to the 0 power. So I really don't even care what 2 times 64 is, because when I take it to the 0 power, it's going to equal 1. Plus, 64 to the 3rd power, just as a review, really means the 3rd root of 64. But once again, you could just put that right into your calc. And that equals 4. So if I take 2 minus 1, I get 1, and 1 plus 4, I get 5. So you should be able to sort of manipulate numbers and different functions and determine what the value is. Okay, you also in this chapter learned how to solve equations that have fractional exponents, and so the main technique that we used was if we have y to the 3rd power and we need to know what y is, if I raise that to the the third power, this is the 1/3 power. Notice 1 over 3 and 3 over 1 are reciprocals. So I'm going to do the same thing over here. So a power of a power I multiply, so then I just get y equals, and this is where you do need to just be a little bit careful with your negative sign. So if I take a -8 and I raise that to the third power, I get -512. Okay, continuing on. This is another situation where when I look at this, what I need to do, because the thing I'm looking for is in my exponent, is I want to get these guys to be the same base. So be suspicious that you probably want to write this as a number raised to a power. And 1/3 is exactly the same as 3 to the -1, for the same reason I was just talking about. So 3 to the -1 raised to the x power. So then I say, well, what can I do with this 9? Well, 9 is the same as 3 squared, and I'm going to raise that to the 1 minus x power. So power of a power, I multiply -1 times x would be -x is equal to 3, 2, and here is a danger zone. Remember, you need to distribute that too. So now, once my bases are the same, I can just set my exponents equal. So -x then is equal to 2 times 1 is 2 minus 2x. And so now I just have to do a little bit of maneuvering here to solve this guy. Go ahead, I'm going to add 2x to both sides. And I get x is equal to 2. So that's using the technique of getting it so we have the same base on both sides. Okay, here's another situation, and I just want to remind you, like, hopefully your brain realizes that you need to raise this to the reciprocal, but don't do that until you get that all by itself. So right now, that 2 is in the way. So now I'm going to rewrite this as x plus 2 to the 4/3 is equal to 14 plus 2 is 16. And now I'm going to go ahead and say, okay, I'm going to raise this to the 3/4, and I'm going to raise that 16 to the 3/4. 4 over 3 times 3 over 4 is 1, so now I just have x plus 2. Your calc would be happy to do this, but I want to remind you, the thing on top is the power, the thing on the bottom is the root. So if I didn't have a calc, I say, well, what's the 4th root of 16? And that happens to be 2, and so the 4th root of 16 is 2, and 2 to the 3rd power would be 8. And to finish the job, I get subtract 2 and I get 6. Okay, so more simplification type problems. Now a lot of these, there's more than one way to approach it, so you might do it a different way and get the exact same answer. I'm going to go ahead and just start looking at what I have. So I'll think of this, remember, this is really division. 25 divided by 5 is 5. Then I have a squared divided by an a to the -2. So that's really 2 minus a -2. Then I have b to the 2/3, and I am subtracting a 1 from that. So now I'm going to go through here with a little cleanup. 5a to the minus a minus is a plus, so this is to the 4th. And if I take 2/3 and I subtract 1, I get a -3rd. We never want to leave a negative exponent, and by the way, if you don't like this, you can use your calculator. So I am going to take that b to the -3rd and just ship it on downstairs where it will become a +3rd. Okay, continuing along, here's another type of problem. Say you are given the 4th root of 81 x to the 5th y to the 12th, and your job is to write it as a power with positive exponents in simplest form. So I would suggest, given a problem like this, one thing you might want to do right off the bat as you see this is realize, is there the 4th root of 81? Is that an actual number? And if you recall, your calculator will help you do that if you're not sure. If you put a 4 on your screen and hit your math button, and you go down to the one that just has an x, which is number 5. Whoops, went too far. Take that back. Start again. 4. I'm going to hit my math button. Instead of scrolling, I'm going to just hit number 5 because that takes me right to where I want to go. And then I'm going to put in an 81, I believe was what the number was, and I'm going to hit enter. And sure enough, that value is actually 3. So if I want to, I can just say, well, the 4th root of 81 is 3, so I'm going to make that come free. Now, remembering this power root thing, I have x, the power is on the top, and the root is 4. And then I have y, this is my power, and the root is 4. And so now I'm just going to do a little cleanup. 5/4 can't do anything with that, but 12 divided by 4 is 3. So that's one direction. The other thing you might get is a problem like this, where instead you're asked to go the other way. So you might be asked to write a radical in simplest form. So power root. So what I'm going to do here is I'm going to say, well, I guess I got to take the 4th root of 16 a to the 5th b to the 6th. Simplest form though means I got to take another look at it, and it turns out the 4th root of 16 is actually 2. Now here's the part that might feel a little bit tricky. Is there some way I can break that a to the 5th down so I can take a 4th root? And I would suggest that I could rewrite a to the 5th as a to the 4th times a. B to the 6th, I'm going to do the same thing. I'm going to rewrite it as b to the 4th times b squared. So you might be saying, well, why the heck did you do that? The 4th root of a to the 4th is a, because the 4th root means that you're taking, the question is what times itself 4 times gives me a to the 4th, and it happens to be a. That a is still stuck, so that a is staying. The 4th root of b to the 4th is b. That b squared is stuck. Let me tell you, the biggest common error here is to forget that 4, because if you don't write a 4 there, it's not a 4th root, it's a square root. Okay, here we go, trying to get through this before I eat too much time up on my clock here. Just another one to solve. Same old, same old. Whenever you're trying to solve and you've got an x, you've got to get it alone. So if I have 5x to the half equals 22 minus 7, which is 15. Now you might be tempted to do something here, but you want this alone. So I'm going to divide this 5 out. So I have x to the half equals 3. And now the question is, what can I do? Multiply 1 over 2 by its reciprocal, which is 2 over 1. And I got to do the same thing on the other side. So I get x is equal to 9. 3 more problems. Okay, here's another one. Just to make a little bit different point, same thing. I need to get this alone, so I'm going to divide this 2 out. So I get x to the negative 1 is equal to 5. Be careful. If it's a negative exponent, it needs to be raised to the negative reciprocal. Well, it just so happens that the negative reciprocal of 1 is going to be 1 over 1, but I got to multiply by a negative. So now I have negative 1 times negative 1 is 1, and then 5 to the negative 1 is the same as 1/5. Okay, number 14, just another one of these problems. I've already done one, but we'll do another one. Be suspicious that you're going to see problems whose bases are going to be 2, 3, 4, more than likely. You're not probably going to get something too fancy. So in this case, 4 squared is the same as 16, and 4 cubed is the same as 64. So same idea here. Now I have the same bases. Power of a power multiply. I get 2x equals, this is the place, the danger zone. 3 times x minus 2 you need to distribute. So this would be 3x minus 6. And so now I'm just going to do a little bit of final algebra maneuverings here. And I get negative x equals negative 6. But I want to divide that negative out, so it turns out x is 6. Okay, this would be it. Last problem. Simplify. A yucky looking fraction all raised to the 3rd power. There's different ways to go about doing this. You could do your power of a power. When I look at this problem, I feel like doing a little simplifying on the inside first. So that's what I'm going to do. So on the inside, I see that I have an a cubed over an a. So a cubed over a to the 1st is just a squared. I have a b over a b, which divides itself out. Over here I have a c to the 1st over c cubed, which would be c to the negative 2, which would keep that downstairs here. But another way to think about that is this c really is basically taking out one of the c's on the bottom. So I have a c squared on the bottom. But I'm not done, because this whole thing gets raised to the 3rd power. Be careful. Everything in here gets raised to the 3rd power. So a squared gets cubed. 2 times 3 is 6. And on the bottom, c squared gets cubed. So that would be c to the 6th. That would be it. So I hope that helps. Feel free, do more review from the book if you feel like there's some problems that you're struggling with.